All right, so go ahead and open up worksheet 14.1 on Canvas. All right, so the really interesting thing about chapter 14 is it's a great review as we get ready for the final of a lot of other things. So we're trying to find out if age and cholesterol are related. And one way we can do that is with a scatter plot. Who remembers how to do a scatter plot? Oh. Jaden remembers? Okay. How do you do it? Highlight both the columns. Enable editing first. I'll do that again. Okay. Insert. Scatter plot. Right there. Now, do you remember how to put titles on there? Click on the green plus. Axis titles. What goes down here? Age and cholesterol. Can't spell. And maybe age versus cholesterol. All right, that was pretty good, very good. Study with Jaden, he remembers. Okay. How do you find the correlation coefficient? Who remembers how to do that the easy way? No, you don't do that. Somebody else in my last class said that. You don't go to the add button for the correlation coefficient. Chapter 4.
You click on a point?
Nope. Nothing to do with the graph.
You can also go to the add chart.
You don't want to add any charts. This is really easy. Should be easy. Guess I should have asked that question before we did the chart. Garrett remembers. Oh. Shay remembers. Equals coral. Thank you, Shay. And then what? Then I don't know. That was a good start. Highlight the first column. Thank you, Spencer. Comma, second column. It was like 2 months ago. Clear out those cobwebs. All right, so now, strong, moderate, weak, or no correlation. Strong because greater than 0.7, okay? All right, now, how do we find the ordinary least squares equation? The easy way. Kendall remembers. Chris remembers.
Wait, what was the question?
How do we find the OLS equation, the regression equation?
That's the R squared value.
Well, the R squared value is the next one. Since you want to do that one, I'll let you.
I'll do that one.
Okay, how do you find the R squared value?
You can click the little plus thing, and there's the trend option.
He likes that plus thing.
Box for the R squared.
You click what?
Trend.
Trend line?
Yep. We'll click on the little arrow next to it.
And the arrow next to it?
And then the more options.
More options.
And then there's the little R squared checkbox.
You know I didn't show you guys that method, but my other class did that too. The R squared, and you can also find the OLS equation doing that.
Oh, so you just want the equation? Oh, okay.
Yeah, I just wanted the equation initially, but you went with the R squared, and I knew it would take you there. Okay, so you can find them both that way. Okay, does that make sense? Do you remember doing that? I said just pick a point. Any point will do. Right click and add trend line. And it takes you right there. So my way was quicker. Okay. All right. Now, all right. So here's the question that we want to ask. is the slope significant? We're going to do a hypothesis test on the slope. What is the slope, first of all?
1.391.
Yeah, so your slope equals 1.3991. Do you remember how to find that without clicking on the point? Can you find that by hand? I'm not going to ask you today, but you may want to study that this weekend.
You take the average of the age, the average of cholesterol, and vitamin.
No. But there's an equation on your formula sheet, so check it out. I'm not going to make you do that today, but see if you can figure out how to do that. I'll probably ask you to do that on the final. Okay? All right, so we think our slope is 1.3991, right? So that's our y equals mx plus b equation. Okay? We want to do a hypothesis test on the slope. Okay? That's what this chapter is about. Up to now, we've just reviewed. Okay? So let's go through our 7 steps. Are the data categorical, quantitative, or regression?
Regression.
Finally, we got to say regression. It's about time, right? End of the semester, it's regression. Okay? Okay, finally. About time. We've been waiting all semester to do that, haven't we? Okay, now,
Why is it regression?
because we're doing this is the regression equation, right? So we're testing the slope, which is that value right there. We want to see if that is significant.
So in a problem, they would ask us to test the slope or something like that.
Yeah, we want to find out if the slope of the equation is significant.
And that's how we do it.
All right, so now, what do you think that the null hypothesis and the alternative hypothesis are? Okay, so okay, slope is significant. What does that mean in an equation form? What'd you say? M equals. Okay, what does null hypothesis mean again? There's no change, no difference. M equals 0. Very good. Okay. What would the alternative hypothesis be? M does not equal 0. It's always going to be a two-tailed test, okay? All right. Now, I'm doing a few things that don't quite follow the book, so let me explain what's going on here. Okay, so in the book, okay, we're used to y equals mx plus b. That's why I'm saying my null hypothesis m equals 0. The alternative hypothesis m does not equal 0. Okay? Having said that, the book writes the equation not as y equals mx plus b. They write it as y equals b0 plus b1x. Okay? So if you write it this way, what should the null hypothesis be? b1 equals 0, and the alternative, b1 does not equal 0. So this is the book. Okay, this is my method. I'll take either one. Okay? But I like y equals mx plus b because that's what you're more familiar with. You may ask yourself, why did they change all those letters? Okay? Here's the answer to that. If you get into more advanced statistics than we are, okay, you're not going to limit yourself to just 2 variables. You're going to say y equals b0 plus b1 x1 plus b2 x2 plus b3 x3 plus however many you got. You could have 30 variables out there. Okay? And so we're just doing simple regression. We're not doing multivariable regression. Okay? And so you're going to have, I mean, they could use M1, X1, X2, X2, but that's what they do. Okay? That's why they do it. That's the convention. If I were writing this, I would have done it my way. Okay? But I will take either method, but this is the method the book shows you. Okay? Just so you know. All right, so now let's go back here for a moment. Okay, we're going through our hypothesis test here. What's the next question that you should ask yourself? What kind of a test is it? Is it a z, a t, a chi-square, or an f?
Is it T
Let's vote.
slope regression?
Who says it's a z? One?
Z or a T?
Who says it's a t? Oh, you voted twice, so that was really a 0. You didn't want the z, Chris?
No, I don't.
Okay, do it again. T. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Who says it's chi-square? Just kidding. Nobody? Who says it's an F? Okay, my other class, I had 3 people that voted the whole time. Okay, you guys actually picked it right. So why did you say T? Because why?
I looked back in my notes.
I can't hear you.
I looked back in my notes.
You looked back in your notes, and your notes told you. Oh, you went through the big thing, the outline? Okay. That's cheating, though. Why? Let's talk about conceptually. Why would this be a T? Don't know the population standard deviation. That's exactly right. Okay, does that make sense? That's a T. Okay, so let's talk about the equation that we have that we're supposed to learn today. So the equation here, I'm going to write it my way again, my way and the book way. So my way would be M1 minus capital M1 divided by S sub M1. Okay? The book writes it as T naught equals B1 minus beta 1. Now, what's beta normally? Type 2 error. This has nothing to do with a type 2 error. I think it's terrible notation. Leave it as M. Divided by S sub B1. Okay? That's the book method. This is my method. Okay, I think that makes more sense. Now, of course, the next question is what, Ethan?
Oh, wait. What was our last question?
Well, the next question after this is, if you're looking at those equations, what do you not know?
Numerator 0. You don't know.
You don't know, yeah, actually, I don't, well, we need to figure out what that is, right?
Yeah.
And then Adam pointed out something else. What does this equal? That equals 0. So really, why do we have that there? It's the bottom.
No.
Okay.
It looks like M1 minus M1. and
It
that's
is lowercase m1 minus capital M1.
Okay.
Your lowercase times capital.
Yeah, sorry. Okay, that's why we asked for clarification. All right, so now let's figure out what. So in here, I'll go with here because S sub B1. Here we'll go with this one because that's what you're going to see on your thing there. S sub B1 is S sub E divided by summation of X I minus X hat. Actually, let me make sure I got that right. One more page. That doesn't look right to me.
Is that capital S, X bar?
Oh, it does have an X bar. I wonder why I have a hat on my notes. That's weird.
Are those capital S's or lowercase?
These are lowercase.
And in the new equation, the SB1 equals SE.
S sub E over Xi minus X bar squared.
Is that all lowercase?
Now we need to know, it's all lowercase. Now we need to know what's S sub E, right? S sub E equals, as I pull this up here, where is it? I'm going to write it this way, the sum of your residuals squared divided by n minus 2. Okay? So my nice simple equation just got a lot more complicated, huh? Okay? Now, who remembers what a residual is?
What's the distance between the point and the
Oh, good job. Say it again.
I didn't hear what she said. The difference
I
from
know
the
she talks way
expected-
too soft. I'll repeat it here in a minute. Go ahead.
The difference from the expected,
The difference from, okay, what's the expected?
the slope, the calculated slope.
Not from the slope. Okay, so Shay is going to speak up and say it again.
The distance between the point and the trend line.
All right, very good. So as we look back at our scatter plot, which is now you know why I had to draw that again, it's the distance between this point and your line. Your line is your expected value, which is kind of what Adam was saying. But it's not the slope necessarily. It's the vertical distance between the point and the line. Okay? So, do you guys remember how to calculate that, your residuals? This is just going to be more of a review day. We got to do all the review to remember how to do this. Who remembers how to find your residual? Yeah, we need to figure out our predicted y. So, how do we find out our predicted y?
Slope times the
Or we're going to move all this out of the way. Say it again.
the slope times the x value.
Yes, so the equation is y equals 1.3991x, and then I moved my thing off the page and I can't read it, plus 151.31. 35 plus 151.35. Okay? So we've got to figure out what our predicted is. And do you remember how to do that, Ethan? Okay, equals 1.3991 times by 25. I'm going to click on it that way. Okay? Plus 151.35. Okay? Now we're going to double click. Okay, now what?
What was that? How did you get that again?
How did I get the first one? Yeah. I just used this equation, 1.3991 times whatever my x value is, in this case 25, plus 151.35. Okay, now I need the observed. Is it squared? Oh, I guess it is, kind of. Yeah. You want to go all in one step, or would you like?
Way easier to do it one step than do one column.
Oh, it is?
It's not as clear.
I don't think it's as clear, though. Okay? If you want to do it that way, you can, but I'm trying to do this. Okay, so the observed 180 minus 186, right? But if you want to do this all in one step, you can, okay? So you can see here, this is off by 6, this is off by 8, this is off by 4.5, okay? And now we need to square that value. That value raised to the second power. We're going to copy that down, okay? Out of the 0 there I didn't really want. And then we need to find a sum, okay? So that's going to be the sum of that column right there. Okay? All right, so that's all you need to do to find the numerator of S sub E. That's it. Okay? All right. So, here, well, this is actually easy enough here. We're about out of time, so I'll just finish the S sub B. We'll do the S sub B tomorrow, okay? So, all right, so all I have to do now is take this number, and I'm going to divide by n minus 2. What's my n in this case? It's 14, so I'm going to take that number, I'm going to divide by 12, which gives me that, and then I'm going to take the square root, equals the square root of that, and I get 19.48. So my S sub E in this case equals 19.48. Okay? All right. So it's all coming back.
Was our N 14?
N was 14. All right, so now, so that's the big review. we're out of time, unfortunately. But here's the deal. I'm going to take this and I'm going to stick it here and do some more stuff. So I don't know what the quiz is going to be on tomorrow, but here's what I would like you to do. I'm thinking it might be good just to review chapter 4 again. This is all from pretty much everything we've done so far, except for these new equations here. But this is really an old equation. Is chapter 4. So here's what I'm going to probably just make sure you guys know how to do a scatter plot and residuals tomorrow for the quiz, because you need to know that really well. Normally when we do this, I say, do you know what a residual is? And everybody goes, okay? You guys didn't do that today.
So tomorrow we'll probably.
So here's what I would say. Kind of attempt to do, I mean, I've kind of showed you everything. I'd kind of like to go through it. But for the quiz tomorrow, just make sure you can do residuals and scatter plots and that kind of stuff. Okay, chapter 4. Okay, so we'll make it more of a review of chapter 4. Yes?
Would it be like S sub B1?
Can't hear you.
For S sub B1, like the top part, not like on the S,
This here?
yeah, xi, the bottom part of that equation. Xi is that the
You can think of that as the residuals for the x variable. You can think of it that way.
Sorry, what?
You can think of it as the residuals for the x variable. So you'll follow the same thing, but for the x variable this time. Okay, so we'll do that tomorrow. Okay? All right. See you all tomorrow. Good luck.